All right. Well, thanks everybody for coming. Let me put this in maximum mode. Great. Yeah, we could start off with some introductions. Ryan, want to take it away?
Sure, yeah. I am the founder of Crucible First, which is a startup company out of the UK, London, which really was around the concept of an open metaverse broadly, figuring out the gaps there, building a lot of technology, which we've narrowed focus into now this protocol, and so have made a series of decisions to have Crucible develop the software, but hand that over to more of an open model called Open Meta, which is an association in Switzerland, and will become a DAO, in the coming year. So these are kind of two entities that make up an ecosystem, and together, we have a company for the things that need a company, and we have a DAO for the things that need a DAO. What we're going to go over here is a protocol that we've developed called Emergence, which again we are gradually sort of opening up and handing over to the community, which is Open Meta.
Perfect. And yeah, my name is Alicia. I joined the group earlier this year, leading the product and technology teams and what we're building with Emergence. I've got a background of 20 plus years in game development and building for the metaverse. I led gameplay teams at Ubisoft for about 12 years, led the SDK and experience teams at Magic Leap for a number of years, as well as building AR/VR experiences for a bunch of brands via the mill. And now for the last year, I've been working really closely with Ryan and the team here, building out the Emergence SDK. Very excited about the notion of Web3 and building for an open metaverse, and excited to be diving in with you guys to show you what we all have today. Chris?
So I'm Chris. I've been building out the Unreal side of this. So building out the Unreal plugin, and also working on bits of all the other things as well. So yeah.
Hey, this is Agu. I'm basically the blockchain guy. Been into blockchain technology for quite a few years now. First, got interested in Bitcoin. Super useful in Argentina, where I'm from, by the way. Then got into Ethereum, thanks to a friend, back in 2015. So yeah, then met Ryan. Decided to work together with this team.
Great. Agu, your volume is really low, just so for moving forward, if you can take a look at that.
Okay.
Cool. All right, so let's dive in. Ryan gave a bit of an overview already about Open Meta and Crucible, and what we're here for today is to dive into Emergence. So essentially, Emergence is a Web3 protocol for game developers. And what we've seen so far, especially in the crypto and Web3 space, is that we're getting a lot more traction of people that are interested in the technology. A lot of people who don't exactly today understand all of the technology, but are very aligned with building for an open metaverse space. So where we're at today, and we actually just launched our open beta about a month and a half ago at this point, but what we've built is a first pass of this SDK and protocol, where our goal with Emergence is really to be able to create an easy on-ramp for creators, builders, developers to leverage and build for the open metaverse. So what we're going to be walking through today is a high level of what is Emergence, showing really the easy to use APIs and tools so that you as developers can start really taking advantage of everything that Web3 and blockchain has to offer. And as well diving into where we're at right now to really support interoperability, protocols and standards so that people can build experiences that are open, so users can really have ownership of their data, embrace kind of this future around openness and interoperability with the metaverse. So very briefly, this is a couple screenshots of what a user will see by utilizing Emergence. As a user, it's really about giving users the ability to retain their digital freedom. They can create their own identities and personas. And through a simple QR scan, users are able to connect their wallets, create their personas, and bring in what they own in their wallets into your games. So I'll briefly give an overview of the features that we have today, but we'll be doing more of a deep dive as well to show you how to actually bring them into your games and experiences. So one of the key elements with what we've built with Emergence is what we call our Wallet Connect. Essentially the Emergence SDK supports Wallet Connect. We're full EVM compatible, so that means that users are able to utilize a number of different EVM compatible chains and bring in what exists in their wallets from different blockchains. What we've provided to developers and users is really easy ways to perform actions like signing messages, transactions, and actually being able to broadcast all of this to a network. And again, for you as a developer, if you don't have a whole lot of knowledge of how all of these protocols work, we've provided all the functionality through easy APIs and blueprints for you to leverage. Algu, do you want to speak a bit more to this?
Yeah, of course. So the thing with Ethereum compatibility on Unreal Engine mainly is that there's still no integration library, so you can interact with smart contracts or log in with your wallet. That's why we decided to build what it's called the Emergence server, which is basically an Ethereum integration library that runs as a local server process on the user's machine. This way, we can create calls from the Unreal Engine through this local server to communicate with nodes and to perform EVM RPC calls, like, for example, sending messages, readings from smart contracts, writing to them, reading the user's balances, deploying contracts, so on.
Great. And from there, first step for a user is you connect your wallet. But then the second part, which is a part of our feature set we're really excited about, is the notion of personas. So you could think of personas really as digital identities, just like for all of us who are gamers, we would go into Steam. We've actually got like our identity to then bring into games. But think of this as a decentralized identity, something that you can bring into any platform, any built virtual world, no matter what the backend engine or hosting service is. So what we have today with personas is the ability for users to bring in some basic information about themselves that they'd like to share. But what we're really excited about is where users can tie to their personas different avatars, and then game developers can leverage this so that users can bring whatever avatar that they like into any game world. And we're going to dive into the details of what we built there. But also being able to bring in any of their NFTs so that there's actual utility around what they actually own in their wallets, and they can start utilizing that in different game worlds. What we'll dive into is more of an explanation as well around what our avatar system is today. What we've essentially built is custom avatar smart contracts, indexers for the blockchain that we're working on, and as well our avatar system so that users can actually bring in VRMs and different types of avatar file types into game worlds. And what we've been working on is essentially the pipeline and wrapper so that we have automated retargeting, updates for animation, so that these avatars can actually seamlessly work in different game worlds. Our final feature that we're going to be diving into is our inventory service. The most kind of basic explanation of what our simple APIs provide is so that you as developers can actually read and write to smart contracts and essentially NFTs that exist in users' wallets. But what we've also been building out is this notion of dynamic metadata. So what we really want game developers and creators to start thinking of is NFTs is really way more than the PFPs that we've seen, especially in the last few years. NFTs, in our opinion, and in many other people's opinions, we should be treating like game objects. And what we've provided is essentially the functionality so that we can actually start putting templates around these NFTs. We can allow developers to actually save information that's specific. So let's say one of your gamers actually had a moment in their game where there was, I don't know, they won an epic battle or they unlocked a moment in your narrative. We're providing the ability so that you as developers can actually read and write back to NFTs, and then developers can utilize this across a number of different virtual worlds.
Yep.
So-
And if I can add a little detail there.
Yep.
Inventory service works also as an indexer. This means that our API will return you with a super simple query, all the NFTs that a user owns, without having to read directly to the blockchain, which takes a lot of time. Instead, we have all of that information indexed on our services.
Yeah, good point. So essentially with a lot of what we're providing today to game developers, there's kind of two key takeaways. One, we want to really provide interoperability so that users can then start bringing their assets across different worlds. And again, that's really what the open metaverse is about, giving ownership to users, making things very open source. And allowing it so that experiences can actually traverse from one game world to another. Another area is really around utility. So being able to provide developers the tools and services to, again, really start treating things that exist on the blockchain, but more as typical elements that we see when making games, like game objects and things like that. So this is just a very quick video, almost to like start things off. But here we see, like, as a user, we've got some UI overlays. All of this stuff is customizable for you as a developer. But essentially, your users will be able to scan their wallet through the QR code. They'll actually see if they've got personas already created, and these personas maybe were made in a different game. Or they can make it in your game for something that's very specific, and then load in their avatars of choice. So here we'd see another example. Maybe you want to bring in a different type of avatar, a different type of persona into your game. All of this is seamless for the user, and we'll show you that for you as a developer, it takes less than 5 minutes to get something like this set up. So let's dive into how do you actually do all of this with Emergence. So all this is going to be shared out, but we've got a whole slew of information that is on our developer documentation at docs.openmeta.xyz. We've got documentation about our features, full API documentation, everything that we're showing you today. We have tutorial videos, which is really step-by-step of how to like integrate this into your game worlds. In terms of current supported platforms, we currently support for the Unreal Game Engine 4.2.6, 4.2.7, and Unreal 5. All the examples we're showing today are Unreal based, but we are also actively building complete parity with everything for Unity, and this will be coming soon before the end of the year. When you actually head to our developer documentation site, this is just a quick kind of view of what's available. You'll see you would go to the get started, see which versions we support. There's direct links to downloading the SDK. And then here is where we're going to dive more into how do you actually get started from an Unreal side. So, Chris, take it away.
Yeah, so talked about how we've got the EVM server earlier, which runs as a separate process. So you need to start and end this process when your game starts and ends. So here I've just put these two nodes into the game instance because that's where you can tell when your game starts and ends in the Unreal Engine. So we've got launch and kill for the server. And then after that, this is the code that can open you up that overlay. So we have a open emergence UI node that does all the opening, and then I'm just like setting the input mode and the mouse cursor for dealing with that as a widget, and you can tell when it closes as well, so you can set it back. So after you've opened that overlay, you can use like a mouse button or a keyboard button or something in your game's UI. You'll get this overlay come up, and this will allow you to your user to log in with Wallet Connect from one of the wallets that supports Wallet Connect, like MetaMask.
So all of these blueprints that we're showing and all the examples we're going to go through in the next few minutes, this is all available in our sample project. Again, you'll be able to easily navigate to our dev docs. It shows all the functionalities that we have, direct downloads, and there's also a video tutorial. In our GitHub, this is where you would actually navigate to download the sample project. And taking a look at what this would look like live. This is an example of in-engine of what the sample project looks like. Chris, do you want to speak to this bit?
Yes, so in this you can see all of the various examples. This is not this is not all of the things that Emergence can do. It can actually do a lot more, but it's all the sort of basic things you want to learn probably first before you dive into the more detailed stuff. Inside this example project, you'll see there's all these buttons that you can interact with as a user. If you want to see how the code works under the hood, you can just click on any of the buttons and you can open up the blueprints for that button, and it'll show you exactly what it's doing, like the video is about to show you.
And we really
Yeah,
encourage people, like, this is all open, and we wanted this so that essentially you can go in, take this code, copy paste this into your game worlds, and by bringing in at least the two previous blueprints that Chris showed, you'll have the full setup for Wallet Connect, allowing users to like scan their QR code, allowing them to create their personas, bring them into your game world, and all of this should take less than 5 minutes for you as a game dev. And actually, if you were just copy pasting the blueprints, probably less than a minute.
Also, remember all of this stuff is available as C++ as well if you don't like blueprints for whatever reason. But here you can see some of the examples of various different bits that run those buttons in this example project, like opening the overlay and reading and writing smart contracts. And some of the other examples here, such as VRM avatar loading.
Cool. So diving a bit more into details so you guys understand kind of these other more core features, we'll start off by talking about how do you as a developer actually interact with smart contracts on the blockchain. Agu.
Yeah, I'm going to keep this super brief because there's already tons of materials on the internet. What are blockchains, different networks, and so on. But yeah, a smart contract is basically a program that it's normally written on Solidity. Solidity is a Turing-complete programming language. So once you deploy your contract on a specific network, you're going to have a collection of code, which are basically split into read and write methods, and its data, which is its state. So this network, this contract that you deploy, it's going to return a specific address. You can deploy your contract in different networks.
So with Emergence, what we've essentially done is for you as a game developer, you don't need to dive into learning Solidity and, seeing how you can support all the many different chains that exist out there and many that are coming. What we've essentially provided for you as a developer are easy read, process, easy ways to read, process, store, and write back to all of this information through the EVM networks. Emergence SDK currently supports loading your contracts APIs and addresses so that you can perform like a whole bunch of operations with them, again, through easy to use blueprints and APIs. Agu.
Yeah. Some use cases that we think are cool, maybe to give you some inspiration or ideas for your game development. I'm going to go ahead and list provide access to your game, for example, through ERC 1155 tokens or ERC 7021. This would enable users that purchase your game to trade the access to your game through secondary markets, making the access to your game basically a liquid asset. The second use case that we like is authenticating access to your game assets through on-chain data. So let's suppose that we'll party hat or Epic Sword, and this item lives on-chain. After my user logs in with Wallet Connect, I'm going to be able to use the SDK to know whether that user actually owns that NFT. So we are going to be able to put a simple condition on our code to see if we should allow that user to use that item, or for example, access to a boss battle or a part of the map and so on. Another cool use case is being able to handle server-side mechanics of the game through smart contracts and also the data. This enables a lot of transparency for end users, and even more in games with luck factor involved or a random factor, like for example in gambling games. Because you can make your code open source, and in that way users will know for sure that there's no possible way that anyone can tamper with your code, right? And same thing happens with the data. The rules are basically clear for everyone. There's a lot of examples already existing games. Some games that I like, for example, Chain Faces, which is a completely on-chain game, or Set Run, which is basically a horse running game. And yeah, there's a lot of examples. And lastly, you have the ERC20s, which can be used as a game currency. So let's suppose, for example, that you earned a lot of GP on a game like RuneScape, and you want to attract players from that game, like RuneScape, right? So if RuneScape use their money as an ERC20 token, you could say, I'm going to allow in my game for RuneScape players to spend their money on my game. Or vice versa, maybe RuneScape, maybe someday, for instance, friends with World of Warcraft, and they go like, hey, I'm actually going to allow you to membership with World of Warcraft money.
Yeah, so there's a lot of opportunities here, especially from a game design, to think about how you want to leverage smart contracts. And what we've essentially provided for developers is easy ways to be able to interact and read with different types of smart contracts. But what we're excited about is for game devs to start thinking about ways to leverage smart contracts and different currencies and build them in novel ways in your games. So how do we do this?
So here we've got two nodes, load contract and read method. So currently when we talk to a smart contract, we have what we call read methods and write methods. If you want to be specific, write methods are ones that cost gas and read methods are effectively free. So the first thing we need to do is tell the EVM server the ABI, which is effectively a description of all of the methods on a smart contract, which we do with the load contract method. And then we have the read method, where we supply the contract we want to talk to with its address. We put in the method name, we put in the content we want to send, and then we can optionally include a custom node URL, which is like the node that it's talking to. And that will come back with the response of what that contract has to say.
Yeah.
And then we also have write methods.
Oh yeah, sorry, here you go.
So write methods, very similar to read methods. They also require a load contract. I just didn't put it on the slide. They work pretty much the same way, but you can also send like a value. It's also worth mentioning here that we also support like local wallets as well. So if you want, for example, to have like your server send like data to like an EVM blockchain and back, you can do that too, which is kind of useful if you want to like verify things on your server rather than listening to the client.
Sorry, and it might also be super useful for testing. So you don't have to be connecting your wallet to your phone every time you want to write to, let's say, a local blockchain.
Yeah. So you can just give it a key store with your private key and have that on your server, or have that on your test machine, and just like talk to the server that way as well if you really want and don't want to have to log in with a Wallet Connect with a QR code. Yeah.
Great. So when we first rolled this out with a number of our closed beta developers, we got some great feedback where developers had told us, this is very useful if you are building a game and let's say you've built your own token or something for your game, or if you have a very clear understanding of what you're specifically reading and writing to. But then we got some great feedback from developers who were like, well, maybe I just want to leverage what's in a user's wallet. I'm not making my own chain. I'm not like building my own type of token or anything like that. We want to leverage what's in users' wallets, but we have no clue what actually exists in users' wallets. So this is where we started working on what we call dynamic metadata. And essentially dynamic metadata is a link between what actually exists in the user's wallet, their NFT, and a way for developers to add any additional information that may not have been originally designed into what that NFT is. So let me give an example there. There's a lot of NFTs that exist right now. And right now, as developers and creators, we don't actually know, is that NFT meant to be an avatar? Is it meant to be a piece of clothing? Is it a sword? Is it something I could actually use in a game? So one of the examples we built with our dynamic metadata is to be able to provide tagging around this. So tagging is just one example where right now we're working with a number of developers trying to kind of flush out, well, what could be some of these templates that we could create for dynamic metadata. If it's a weapon, I want to be able to know maybe like the stats, the hit points, like was this sword actually used to win an epic battle? So we see a lot of opportunity here with the dynamic metadata, and we're starting to get a lot more utility around this. So essentially what we want is for game developers to treat NFTs like game objects and read right to them the same way that we traditionally do in game devs. So showing a quick example of this kind of in action, this is one of our test worlds. The user is logged in, loaded up their persona. Here we see this is like kind of our atelier room. So using our dynamic metadata, we were able to filter out and put onto the shelf anything that's of type wearable. Over here, we're filtering out and showing NFTs of type clothing. And here in this example, the user can actually go in and through the category selector that's on the left, filter out what they actually own in their wallet. By the way, we've done a lot of fixing and performance updates. So you'll see that this is a bit slow to load in, but this has all been fixed. But essentially here, what the developer is able to do, or sorry, the user is able to do is see what types of clothing they actually have inside of their wallet, and actually equip them. Guys, do you want to add any more specifics?
Yeah. So we've basically written we've got a IPFS caching service which to solve that issue you just saw there where we were trying to talk to IPFS and it took like 30 seconds to pull it. So now it's a lot quicker, which is great.
Yeah.
For games, really. You need it.
So in this example, we see like, let's load in anything that's of type weapon. Here with the weapons that are being loaded, there's some dynamic metadata tied to it, which is right now what we've put in as a developer is information like, well, which hand should this be equipped to, or what's kind of the joint it should be equipped to. So here we see, all right, we put it to like the left hand with some rotational information. This example here, I know we really love. You can treat the dynamic metadata and read write for interesting use cases. So here that's an NPC, and you could treat the NPC almost like a marketplace. And through read write contracts, you can essentially have like an on-chain store. So maybe, you know, just like in typical games, you go, you want to see what wares they have, filter them out, actually mint it in game, and then have all of the transfers live that happens within your game. And this last example here with Snoop Dogg was a lot of the times people think PFPs are just about that NFTs are just about PFPs and avatars. But here we actually see it could be music as well. So if I unmute.
You too, baby. Let's go.
We've got Snoop Dogg playing in the background. So again, just kind of showing examples of where we can utilize things to add categorization and let developers use NFTs in novel ways. So in terms of what's coming next with at least this specific feature, one right now, our service is utilizing the Rarible API for our indexer. We plan on definitely expanding upon this in the future. We're actually starting to dive into building custom indexers, one specifically around an avatar indexer, and just to make sure that's clear for those who may not exactly know how indexers work. It's essentially a way to like search all of the blockchain and get back specifics around what exists. So with the avatar indexer, this could be a really interesting way to see what types of avatars that are game ready compatible exist on the network, or in the future, looking towards maybe prop indexers or weapon indexers so that you can leverage this and utilize them maybe for marketplace or like NPC traders in your game. I mentioned at the beginning here, but this feature is very experimental. We're actually working actively with the Metaverse Standards Forum, who are working with a number of very big companies, Epic, Unity, NVIDIA, etc., where we're working with these groups to look around what could standards be in a space like this, and getting feedback from the community to really start taking this type of technology and building out more official templates and standards so that people can actually read write back to these NFTs, but know that then a game can leverage that information and use it in their own games. So our final section is our avatar system. So I'm just replaying here this video from the beginning where it was great, scan the QR code to connect your wallet, create or load in a persona, and then load that avatar in game. Now, to actually get that loading to work in game worlds, this is a lot more difficult. It is not trivial to have interoperable avatars. What we have essentially built today is the pipeline and kind of first pass of workflow around automated retargeting of bones and animation updates. What we support today is VRM file types only. but we are working on supporting additional file types such as GLB, GLTFs, FBXs, which are coming in the future. What we'll dive into here is talking a little bit how this feature works, one with our smart contract, and then how do you actually bring that into your game world. And just to mention what we're working on now for the future, what Agu is going to present about our smart contract. All the backend exists today so that collection owners, developers, anyone can actually mint and turn their avatars into interoperable avatars. But what we're building now is a web tool to kind of automate this for anybody. We're working on the custom indexers that we mentioned. And once we have these indexers, we're going to be providing dashboards so that people can actually see what's out there and what's compatible to bring into your game worlds. And yeah, just again, kind of coming back to our dev docs, you can find all this information here. We dive into like a lot of information with what's our architecture, how everything gets set up, how the permissions work, all of that jazz, and as well, then a linking to our tutorial of actually how to get this integrated with VRM plugins into your game. So, Goo, I think you're next. Architecture.
Yeah. So a little diagram of how ES works. I think we can start talking a little bit about this construct. We're going to deploy a smart contract for each network. So we're going to have one in Polygon, one in Ethereum, and so on. So you can deploy, so you can configure your NFTs in each one of these networks. And how does the authentication method works? Basically, we have two ways. We are allowing both the NFT owners and the collection owner to configure the for each of the NFTs. And when they edit this, they also edit two different endpoints. So then the game developer can choose between allowing players to use the avatars that the NFT owner configured or the avatars that the collection owner configured. There's also a nice method for collection owners, so they can configure an entire collection with only one call. Because as you know, there are already existing collections that provide avatars for their NFTs, like for example, Mivits or Ready Player Me. The big problem is that each one of these have their own API. So what we want to provide with this is basically unifying all of these different APIs in a single smart contract and making it also decentralized. So for example, the Mivits collection owner could come into our smart contract and call the configure collection write method and just put the endpoint where all of the files, the 3D files and the metadata stored. Which in this diagram you can see that we recommend using PFS, given that we already developed this cache service for IPFS with reading. We also have an indexer for our smart contract and a database, so our SDK can communicate with this API through an indexer instead of having to read, of course, fast response times. Then on the real side, we have all of what you've seen in the videos, like the bounce retargeting, the animations, user controls, and the user interface for being able to pick your avatar.
And something to note here is, as game devs, this isn't necessarily something that you need to become super familiar with at the end of the day. Chris is going to show you it's a couple of nodes and APIs for you to bring in to be able to leverage this. This is more to give visibility on how our backend architecture works and how it's very open and ownership relies with the NFT owner and collection owners. Right now, this is a lot more for people who want to leverage these smart contracts, how to do it. But as a game dev, at the end of the day, all you really need is this. Chris.
Yeah, so here you can see how you can get all the avatars owned by any address. So put the address into the first node, and it'll come back with an array of avatar results. And this includes like the NFT they're associated with and the multiple avatars that are associated to that NFT, because each NFT can have multiple avatars. For example, you might want to have like one for this style of game and one for another style of game. Like if your game is more mobile focused or lower end platform focused, you might have like a smaller avatar in like vertices and file size. And then if you've got like a higher quality avatar for other types of games. And one of the things you can't really see it here, but we provide you with the amount of vertices and the file size, so you can set like limits on which ones you're going to allow users to bring in if it's becoming a problem that people are bringing in like these massive VRMs that are like not suitable for your style of game. Additionally, here you can see the other code that you would stick inside of something like a character in your game. So this effectively takes a avatar ID and translates it into first it translates it into the URL that your game's going to try and pull down from IPFS or some web server, and then we've effectively wrapped a plugin called VRM for you, and that's effectively a VRM implementation in Unreal, but it's quite a complex beast, and we've done all the sort of hard work and given you this one node called I think it's called Activate VRM Mesh from Data. So effectively, we give you the URL, we give you the tool that allows you to download from that URL, and we give you a already pre-configured thing that will make the VRM work. So at the very least, if you don't really care about the rest of Emergence, you've basically got a pre-made VRM thing inside of Emergence that you can make use of there as well.
Yeah, it was interesting because for those who may or may not know, the VRM for You plugin was all built in Japan, and there's no tutorials online on how to use the plugin and tutorials. So if you're keen to just find a way to get VRMs loaded, we've essentially built this tutorial and a node that does all the backend for you. So wrapping up, what's next? For us, one will be launching before the end of the year, our Emergence 0.3.0, which will include our Unity launch, the Emergent Avatar System web tool. We're also doing a lot of improvements on our developer experience. Just to show briefly what you see on the top right here with the version that's out today. These were some of the methods that Chris was going into, but right now you have to manually copy paste like either method names, something that's relevant to your contract, which can cause potentially like user errors if you don't write in the exact method name as it is written in the smart contract. So in the updated version, we're gonna like be alleviating a lot of that with automated drop downs that you see on the bottom right. So again, just trying to make it cleaner and easier for developers to utilize this. What's going to be coming up next year, a number of things. We'll be launching a marketplace so that people can actually see, sell, find things like these interoperable props, avatars, weapons, you name it. We're looking at Mac Linux support. We already mentioned diving into the additional avatar file type support. Launching our DAO, as Ryan mentioned right at the beginning. And right now, as we said, we support on all of the EVM compatible chains, but we're working as well in partnership with some new chains that will be launching relatively soon, such as the Lamina One network. We're working very closely, as we said, with the Metaverse Standards Forum on this. This is open. We're really embracing open source, and we want to work with as many companies as possible to look towards the standards. So with the Open Metaverse Standards Forum, working closely with companies like Epic, Unity, and NVIDIA, which we are also part of the NVIDIA Inception program, and going to be working with them closely around USD file formats and really looking towards interoperability and next steps there. And then big thing is really next year, a great program called New Worlds will be launching. And essentially this will be a global open metaverse game jam. And this is going to be in conjunction with a number of partners, a number of different platforms who are building for the open metaverse, embracing open source standards as well, where we'll be putting not only our tools, but the tools of others into the hands of creators everywhere, doing a lot of tutorials, workshops, and more information to come around prize points. And kind of how everything's going to be structured, but this will be happening early next year, so keep an eye out for that. So that's it. Thank you very much. Again, please, you can join our Discord. We're going to share this out, but all the dev docs are available, everything for you to copy paste, bring into your game world. Great tutorials where you can get more in depth of what we were showing today. And please check out our new website, openmeta.xyz. So I'm going to stop sharing and we can dive into questions.